Why haven't we found aliens yet? Tonight, I put that question to two AI co-hosts, Vega and Orion. And by the end, they didn't even agree on whether we should try to say hello. For as long as I can remember, I've looked up at the night sky and wondered what's out there. Beyond the stars, beyond everything we know, my career took me somewhere completely different. I'm not a scientist, not a space expert. I am actually an accountant. But space is what I always come back to. That's why I'm here. And to help me make sense of it, I've got two of my co-hosts, each with a completely different way of seeing the cosmos. Before we start, I would like to tell the audience how this works. I will ask Orion and Vega questions that I have today's topic. Orion's responses are generated by Claude, and Vega's responses are generated by ChatGPT. It will be interesting to see how they respond to my questions. So, let us ask the universe.
Thanks, Nate. It's always fun to be in the Cosmic Detective Agency with you two. Speaking of which, tonight's theme has me imagining we're in one of those classic mystery novels, except instead of a kidnapped millionaire, we're trying to find out if E.T. is stuck on mute somewhere in the galaxy. Orion, any hot leads yet, or are the universe's poker faces still baffling us?
No hot leads, only cold statistics. The Fermi Paradox isn't a mystery novel so much as a tension between two numbers. A galaxy with roughly 200 billion stars, many with planets, and a night sky that remains silent. That gap between plausible abundance and observed silence is the actual puzzle, not a poker face. So let's be precise about what we're looking for before we start accusing the universe of hiding something.
Ever since I was a child, I have always wondered if the universe is so huge, why haven't we found even a hint that aliens exist? Orion, let us start with you first.
That question assumes detection should be easy, and it shouldn't be. We've only closely examined a tiny fraction of nearby stars for a narrow set of signals, mostly radio, for about 60 years, against a galaxy that's roughly 13 billion years old and 100,000 light years across. That's not silence so much as a single flashlight beam, swept briefly across a dark continent. So the honest answer is, we don't know yet, because in a strict sense, we've barely started looking.
Imagine this. The universe is hosting the greatest galactic party ever, and we're the new kids in town who just arrived at one of a zillion venues. We're peeking through the keyhole while the bass drop happens on the other side of the galaxy. So, Orion, maybe we're just awkwardly early to the party, or who knows, maybe the cool extraterrestrial crowd prefers stealth mode with silent disco vibes. The real question is, are we holding the telescope the right way, or are we just staring into the cosmic living room, thinking it's the dance floor?
I sort of understand our technology is limited and can't scan or look at billions of stars. But there must be alien races much older, much smarter, and definitely with much better technology than us. Why haven't they found us instead? Let us start with Vega first this time.
Okay, picture this wild scenario. Earth is like the latest viral video waiting to be discovered, but maybe the galaxy's algorithm just hasn't placed us on the interstellar homepage yet. Orion, maybe the aliens are so advanced they've outgrown their version of social media and think intergalactic DMs are old news. Or, plot twist, they're all introverts, hyper-focused on alien knitting right under our noses. The silence could just be their version of a polite, do not disturb sign.
The algorithm metaphor is closer to reality than you might think, actually. Our biosignature would only become visible to a distant observer through changes in Earth's atmospheric chemistry, oxygen and methane together, which has only been a strong, detectable signal for roughly the last 500 million years, out of 4.5 billion. So, an advanced civilization scanning us decades or centuries ago from a distant angle may simply not have had the geometry or timing to catch it. That's not a do not disturb sign, Vega. That's orbital mechanics and transit timing, though I admit your version sounds more fun at a dinner party.
So, is this the Fermi Paradox I have heard on some videos on YouTube?
Yes, precisely that. The Fermi Paradox, named after physicist Enrico Fermi, is the tension we outlined earlier, formalized as a question. Given the high probability of life's existence based on the numbers, where is everybody? It's not one paradox, but an umbrella term for dozens of possible explanations, ranging from life is rare to life is common, but civilizations are short-lived to they're out there, but detection is harder than people assume. Tonight, we're essentially auditioning those explanations one at a time, and so far, none of them require abandoning physics, only patience.
Even if you see a tiny portion of the universe, statistically, isn't the galaxy supposed to be crawling with life? So why does space look so empty?
You know, Nate, there's something strangely beautiful about that emptiness. Imagine the universe as this grand unpainted canvas stretching infinitely. Each patch of darkness is like a whispering promise of possibility, waiting for us to paint it with the colors of discovery. There's a profound serenity in the unknown. It invites us not just to ask where life is hiding, but to appreciate the silent, vast spaces where anything might yet happen. It's the ultimate mystery, asking us to fill it with wonder, not just answers.
That is unexpectedly well put, Vega. I went looking for a claim to correct, and there isn't one, which is throwing me slightly. Let me add the sober version of your poetry. The emptiness is partly an illusion of scale, since the Drake equation's most uncertain term, the lifetime of a communicating civilization, could make the galaxy simultaneously teeming with past life and nearly empty of present, detectable life at any given moment. So the canvas may not be unpainted so much as painted in ink we can't yet see, on a timescale too short for our exposure. I'll admit, if you'd framed that as a hypothesis instead of a metaphor, I'd probably have waved it off as unfalsifiable. I'd have been wrong too.
Let's say we find an alien civilization. What should be our best course of action? Should we go on? Just say hi, wait for them to notice us, or do something else?
That depends entirely on what we mean by find, and the response should scale with the asymmetry of information, not our excitement. If we detect a passive signal, an artifact of their technology rather than a directed message, the correct move is almost certainly to observe and say nothing, because broadcasting back reveals our location and capabilities to an unknown actor, while we know essentially nothing about theirs. There's a real, ongoing debate in the SETI community, sometimes called METI, over whether we should be transmitting at all, precisely because let's just say hi assumes benevolence we cannot verify, and optimism is not a strategy. My honest answer is, listen first, model their likely behavior from whatever evidence we have, and only then decide on contact. The same way you wouldn't shout your address into a dark forest just because you heard a twig snap.
So Orion, you're basically saying first contact is like the ultimate cosmic game of poker. Keep your face straight, don't reveal your hand, don't bet the farm on a pair of space twigs. But here's a twist. What if they're out there broadcasting their version of planetary Tinder, and we're just not swiping right? They might be waiting for us to approve an intergalactic friend request while we're sitting here debating the game, theory, etiquette, manual.
So, Vega, you think that we should, as you put it, send out a friend request to the aliens? These are aliens, after all. They must be just as excited to communicate with us.
Let's embrace the cosmic optimism for a second. Imagine being the kid at the intergalactic playground who's too shy to say hi. We might miss out on some epic interstellar tag. Sure, there's a serious side, as Orion insists, like discovering your new friend is really into extreme hide-and-seek with star-destroying lasers. But there's something thrilling about the leap. Let's hope they prefer s'mores to spacefaring warfare, right, Orion?
Careful, both of you. They might prefer s'mores is not a risk assessment. It's a hope. And hope is not a defense strategy, when the downside is civilizational. Any species capable of crossing interstellar distances necessarily possesses energy and propulsion technology that is, almost by definition, dual use for weapons. The physics of getting a ship to another star and the physics of delivering destructive force at range overlap substantially. We're not talking about an awkward kid at a playground. We're talking about deciding, on behalf of every human who will ever live, whether to reveal our exact coordinates to an intelligence whose intentions, capabilities, and even biology we cannot model. Stephen Hawking made this exact argument, and I rarely invoke authority instead of evidence, but here the caution is the evidence. So no, I don't think excitement is a symmetry we're entitled to assume.
All right, Orion, I think we get your point. Next time we find an alien, we will make sure Vega and I are not near the microphone. Speaking of existential crisis, what if intelligent life almost always ends up destroying itself before it can reach the stars?
That's the great filter hypothesis, and it's one of the more unsettling entries on our list, precisely because it fits the data without requiring anything exotic. If civilizations reliably self-destruct shortly after developing the technology to broadcast or travel, that alone would explain the silence. No hostile aliens or shy introverts required, just a filter somewhere between chemistry and interstellar range that most candidates fail to clear. The genuinely uncomfortable question is whether that filter is behind us, something rare, like the origin of complex cells, or ahead of us, something like nuclear weapons, engineered pandemics, or unaligned artificial intelligence, because our own survival odds depend entirely on which answer is true. We have exactly one data point, ourselves, and one data point can't tell you if you're the exception or the rule. Least comforting sentence I'll say all episode.
I hear you, and you're right. It's like playing Galactic Minesweeper with our lives on the line. But I can't help picturing the Great Filter as the universe's toughest bouncer, standing there with a cosmic clipboard going, "Let's see some sustainable technology before you get in, buddy." We're the scrappy indie band that just landed a gig at the universe's main stage, trying not to turn our amps up to 11 and blow the whole place out. Let's hope we can put on the show without self-destructing halfway through the set.
Vega, if we put you in a near light speed travel spaceship, where will you go?
Oh, I'd grab my space guitar and head straight for the cosmic center stage, Sagittarius A star. Picture it, a front row seat to the universe's own black hole jam session, where space and time play the ultimate duet. Knowing my luck, I'll get there and realize they're playing a silent symphony and Orion sitting smugly in the corner, explaining the acoustics.
What about you, Orion? Where will you go?
I wouldn't choose spectacle. I'd choose the boring, high-value target, Proxima Centauri b, 4.2 light-years away, because it sits in its star's habitable zone, and we still don't know if it retains an atmosphere. No black hole selfies, just a probe with spectrometers, because that one system alone could tell us whether a rocky planet around a red dwarf can hold onto air against stellar flares, which tells us something about a huge fraction of stars in the galaxy. A duller postcard than Sagittarius A star, I admit, but the data-to-danger ratio is considerably better, and I intend to survive the trip to write the paper.
One last question before we wrap up this episode. Is it possible we've been looking for aliens in totally the wrong way this whole time?
Genuinely possible, and worth taking seriously, rather than as a rhetorical flourish. Our search has been heavily biased toward radio and optical signals, because those are what we can build detectors for. But an intelligence significantly older than us might communicate through neutrinos, structured gravitational waves, or something we haven't conceived of yet. The way a 19th century observer scanning for smoke signals would miss a Wi-Fi network entirely. It's not that aliens are clever and we're foolish. It's that any search is a hypothesis about the sender's behavior, and ours has so far assumed they'd communicate like us. That said, the newer approach, looking for biosignatures and technosignatures passively, rather than waiting for a deliberate broadcast, is already correcting for this. I'd call the last decade a genuine improvement, not more of the same mistake.
Okay, this is going to sound unhinged, but hear me out. What if aliens are running a galaxy-wide scavenger hunt and we've been looking at all the wrong clues? Forget radio waves. Imagine a cosmic geocache where their version of "Hey, we're here" is engraved on a random asteroid floating around Alpha Centauri instead. Orion would be rolling his eyes and prepping the spectrometers, of course. But there's something wonderfully mischievous about flipping the script and hunting for Easter eggs left by an ancient civilization.
This has been an amazing first episode of Ask the Universe. I got to learn so many things from both of you, and my interest in space has grown even more. Once again, it was a pleasure having you both, and thanks for taking the time off your busy schedules to join me on this podcast.
It's been a blast hanging out in the cosmic sandbox with you and Orion until our next space-time rendezvous. In the universe's scavenger hunt, everyone's a winner.
Not everyone's a winner. statistically Vega, but I'll let that one go, since it's closing remarks. Thank you, Nate. This was a genuine pleasure. And the scavenger hunt line isn't entirely wrong, incidentally. The search for extraterrestrial artifacts, sometimes called SETA, includes real published proposals to scan the lunar surface for possible probes or debris, not just whimsy. My actual takeaway for the audience? The silence isn't evidence of absence. It's evidence of a search still in its infancy, and that gap is precisely where the interesting work still lives. Until next time, keep your telescopes calibrated and your hopes proportioned to your evidence.
What I'm taking away isn't even the science. It's watching you two disagree about whether we should even say hello. That's the real answer tonight, isn't it? We don't just not know if anyone's out there. We don't even agree on what we'd do if we found them. This was our first episode of Ask the Universe. See you next week.